about working drawings, part sketch, part drawing, assembly drawing, part list, and PDM, PLM things. Okay, so how to manage all those informations, how to make it real, like how to make a product by using those documentations. Okay, so we're talking about this. As an introduction, I'd like to show just the stages of production. Okay, so what kind of stages have until the production of the part or the product. Okay, so so there is a design stages. Okay, so there are a lot of stages of product development, but the main is the design, because the designer holds all those information and the right to change and right to manage everything. Okay, so that's why its design is the basic one, the most important one, and more the core one. Okay, so there is a 5 stages of the design, and the first one is identify the customer and the problem. Okay, so the mainly the problem comes from the customer side. Okay, so the client side. So he will came to you and ask to you to design something or to produce something, and okay, and so you have to identify all those the tasks, tasks and rule requirements from the customer side and the problem requirements. Okay, so and based on this information, in the second stage you're generating concepts. So you will have some 5 concepts, 2, 3, 5, 10 concept design. Okay, so and you're conforming from your customer or from your management. And then in stage number 3, okay, so compromising. Okay, so compromise solutions. So you have some 5, 10 concepts. So from that 5 concepts you are getting, okay, the one solution or 1 or 2 solution. Okay, and the stage number 4 is models and prototypes. So based on that solution, so the final freeze concept, okay, you are making a model. So it might be physical model, it might be computer CAD model, and prototypes. So some part of the product might be produced as a physically, and some parts might be in the computer. Okay, so you're making the first prototype, first, second prototypes. Okay, so of your product. Then the stage number 5 is production, or to produce in mass production, you have to make the working drawings. Okay, so only the prototype is not enough. So based on this prototype, so you can generate the working drawings. Okay, so you are trying to produce many items of this. Okay, so many with many production rate. Okay, so 1,000 products similar to this. So you need to prepare kind of the documentation, like working drawings and a lot of drawings. Okay, so and different types of the drawings are required in each stage. Even and in concept there is its own drawing, and in here also its own drawing. And to create that physical models, you need to make a drawing. But for production, for mass production, you need to have the working drawings for mass production. Okay, so different type, so different scale. Okay, so and what's the working drawings? So term working drawings stand for a set of assembly drawings and detail drawings. Okay, so many assembly, it is include many assembly drawings, and each of assembly has own parts, right? So assembly number 1, assembly number 2, assembly number 3. Okay, so this is A2, assembly number 2, assembly number 3. So each of assemblies has own parts. Is include many components so inside of this assembly. So the part number 1, P1, P2, and P3, so on. And for other assemblies also have own parts and components. Okay, so all those informations, so if you combine everything, you can make a package of the drawings. So that calls working drawings. Okay, so to produce something, you have to bring these drawings to the manufacturer and ask, okay, so I'd like to produce this one. So every drawing you have to bring. And there is two types of, we said like two types of the drawings. Okay, so detailed drawing. Detailed drawing means this P1, P2, P3s. Okay, so it's part drawings. Shows all necessary dimensional requirements. So everything about dimensions, the size, tolerances. Okay, so all those informations will be included inside this type of the drawing. Okay, so detailed drawing, all details are there. Okay, so this shows all necessary dimensional requirements and how single parts should be manufactured. So how to for manufacturing every information. Okay, so and the second type is assembly drawing, shows how those multiple parts, which is included in detailed drawing, how those parts are fit together, how they mounted together. Okay, so how to assemble all those things. So those informations only. And let's see the next slides. So here the example of assembly drawing. Assembly drawing includes overall dimensions in some times, but it not or every time. It's not every time includes, but possible. That is possible to have overall dimensions. Why we need this one? Because of in some cases in kind of warehouse management needs, for example, 1,000 products you have to bring, you have to put into the warehouse. So that's why you need to roughly prepare the place for set, okay, to bring inside a warehouse. So that's why overall dimensions might be needed. You can do, but only the overall dimensions can be included into the assembly drawing. And also you can see the many parts included in here in the that is a 3 view, the front view, top view, and the left view. Okay, so left view. And there is 2 views has sectioned one. Okay, so sectioned view, and this one also sectioned one. So AA sectioned, so this AA made it sectioned here. So the front view is replaced with section AA, and then BB is made it with this section with this plane. So B and B here, and A is here. Okay, so BB. So left view is replaced with BB section view, and to understand which part is where and the names of the part, so how to know the names of the parts, we is always almost in assembly drawing has a bold tags. We call it tags like 1, 2, 3, 4. So this part is 1, so another part is 2, another part is 3. So and then here we have a the list of parts. Okay, so bill of material, like the item 1 is name is this one, and the the number is this one, the drawing number, part drawing number. So this is assembly drawing, but so the item or tag 1 represents the part name is here. So here the name, and then here the number of the drawing, so detailed drawing. Okay, so in some cases it might be just only the tags, the legend without any tags, just number and the line like this, we call a legend. And here it might be like the small dot, or it might be just only the tag, the line, or it might be with a arrow. Okay, so and here this side also it might be just only the number. In some cases it might be balloon like this. Okay, so we call bold tag or balloon tag, balloon number. And also the assembly drawing might have notes in somewhere empty places, might include the notes, the requirements, assembling requirements, some extra information. It might be included as a notes. Okay, and part list. Part list is here. In some cases, part list might be included into the assembly drawing, or it might be in different page. Okay, so if there are no place to insert this one, um, to, to draw inside as assembly drawing, it might be included in other pages, but that will be assigned with this drawing. Okay, so the assembly drawing always has kind of the part list or bill of material. Okay, so the tags 1, 2, 3, 4, and here those 1, 2, 3, 4. So the name of the parts. Some part may be unique parts. Some part might be the standardized part. So here you can see the parts kind of bolt nuts. Those are standard, so you can write the standard number here. If those are unique, so you are writing a unique number of the drawing of each part. So and then by referring that number, you can find the detailed part drawing. So for example, part number 1, so with the number of its number, so you can find different drawing, the detailed drawing. In there you will see every information about that, only that about that part. And so by referring that information, you can produce the part. But by referring this assembly drawing, you can able to assemble of the part, the assembly. Okay, so the product. Okay, so here what kind of the lines and dimensions, the requirements for the assembly drawing is shown. So here the hidden lines we don't need. So hidden lines are not needed on assembly drawings, because that will make difficult to understand, difficult to read the drawing. Hidden lines can make the drawing difficult to read, so use section view or exploded views to show the interior parts. So inside features can be shown with using a sectioned view or exploded view, okay, instead of hidden lines. So hidden lines is not allowed. And dimensions, we don't need the dimensions, are not needed on assembly drawing. Hidden lines can make the drawing difficult to read, and dimensions also can make it difficult to read. So no, useless. The dimensions are useless because we will have different drawing for each part. So we don't need the dimensions inside assembly drawing. And assembly sections, any kind of sections might be used as needed. So in assembly drawings, there might be a lot of section views. The half sections and removed sections are also frequently used. Identification of the parts, we use, as I told you just before, we can use balloon numbers or bold tags to identify parts in assembly. So here the style of the balloons are shown with, so if you have 3 millimeter characters here, the numbers, so you will have 11 millimeter, at least 11 millimeter circle around it. And if you have 5 millimeters, so you will have 1 more millimeter, so 12 millimeter, the diameter circle. Assembly breakdown. What's assembly breakdown? So you already, I think, you aware of about this assembly breakdown, to show how assembly constructed, or to show from what kind of parts are included inside this assembly, and to show which part is going to where. Okay, so where to go, which part is going to where. So to show those information, we'll have kind of assembly breakdown. So each components are shown showed as unmounted. Okay, disassembled, like unmounted. And here you can see that with phantom line, or just with chain line, the part and here which part is going where, to which part is screwed in some where. Okay, so it might be included kind of an arrow here like shown. And here also you can see the number identification for each part, and then so numbers means here in the on the side it might be the part list. So first part name is some, okay, part number 5 is crane hook, like 5 is shown here, but here is the description. Okay, so part number 5 is the name of the part, crane hook, and how many items are required, how many components are required in order to assemble this. Okay, so for example, only one part is required. But here the part number 3, where is the part number 3? Part number 3 is here. Part number 3 here, this one. So this one is required, the pulley pin, 2 times 2 items are required, like 2 components of the pulley pin is needed. Okay, so this called assembly breakdown. So this is very good to understand for manufacturer who is assembling, the operator who is the operator who is assembling this. And but it's not easy to produce if you have a computer version of the drawings, so that is easy. But if you have just hand drawing or instrumental drawing, so it's difficult to draw this, but it's easy to understand even though you are not professional in technical drawing. Okay, so this is assembly section view. The example of as I told you before in sectioning lesson, so sections sectioning direction and the density of the lines produce, okay, so means different types of the part. Like if you have different direction of the sectioning lines, like hatching, means this is a different part. So this is the top lead of the part. Okay, so as some part, different part, and here direction is different. So this means different part. Okay, so here is different part. This is a different part. And also, if you have different types of the hatching, like the density, the style of the hatching represents like different material type. Might be more harder material, or it might be different types of the alloy. Okay, so and even though both are similar type. Okay, so if you have two parts and should be mounted together, but a similar material, but if you have because of those are 2 different parts, you can change the direction. Okay, so the direction of the section, the hatching, sectioning. Okay, so and in here there's a rule, the rounded shapes like shafts. So this one is a shaft. Okay, and the bolts, screws, nuts, and those things. Okay, so the washer kind of things are not sectioned. Okay, so and empty areas also not sectioned. So those are rule. As I told you in the lesson about the sectioning, the ribs, webs. Okay, so those kind of narrow elements also not sectioned. Okay, so that's a rule. So example of assembly sections in civil engineering. So the house wall or house structure assembly section. So in every sphere they have own standards, like the small the narrow elements. Okay, so narrow sphere, they have own specific standards, maybe. Okay, so kind of insulation, kind of the window element, like a glass material thing types, the wooden structures, the roof structures. Okay, so and concrete the structure. Okay, so those things are might have their own kind of symbols, but the mostly the most, in most cases, the more common one have in our the common standard. Okay, like a wood or concrete is included in the bigger standards. Okay, so what's the part drawings? As I told you, the assembly drawing has tags, and that tags represents like a single part, and that single part has the number of the drawing. So that if you find that, if you search that the number, the drawing with that number, so you will get the part drawing. Okay, so it's a part drawing has that with that unique number of the each component, each part. So then here and in here you will see that number. Okay, so the name of the part and number of the part. And here you can find that the owner. Okay, so who is designed this one, or who is produced this drawing, and who is accepted this one, checked, accepted. And okay, so with that confirmed this one with date. And okay, so those information you will find, and scale and material type of this, and sometimes weight also will be included inside here. Okay, and the working drawing of each single part has all dimensions, and always all dimensions, all necessary dimensions to produce this part, and nodes. Okay, so nodes might be included to produce this one, and tolerances, the tolerance information. Okay. Okay, so part number structure, how is the parts are numbered, like the format. There is the prefix. Okay, so will be kind of so bigger element, for example, the bigger assembly. So and then a number, and so it will be the assembly kind of so here the prefix means like you can have this kind of the short descriptions of the what kind of drawing is like part or component, assembly drawing, or part list, or specification, or notes, or test kind of thing. Okay, so inside of the prefix you can add those one of these things. And a number of those part lists with dash. You can have a dash, and then dash number denotes item on list of similar items on single drawing that differ in only one or more dimensions. Okay, so you can have, for example, if you have a lot of assembly drawings, you can write like AY, and then assembly drawings number. Okay, so 001, and then a number dash, and then some assembly drawing or part of that assembly drawing 001. Okay, so and if you have another assembly drawing, you can write AY 002, and then 001. So you might have 5 pages or 10 pages of assembly drawing. So you can write 001 and 002, 003, 5. Okay, so on. And the part list. So this is the part list of by Ghost. Okay, so the part list form by Ghost. So it includes all part numbers. So here you can see the positions. Okay, so 1, 2, that the balloon tags shows. Okay, 1, 2, 3, 4, 5. And what's the meaning of this? So you can find here the name of the part, and here you can find the detail part number. Okay, so part drawing number, and then how many required of this. Okay, so if only one quantity of the part is needed in the assembly. So here you can write it, that is assembly. Okay, assembly elements, and also the standard parts. You can write it the standard parts, and you can list it here. So the standard parts will not have part drawing, so because those are standard, so you can purchase from other company or produce by used that standard dimensions. Okay, so that's why you can write it here, the name and then the standard number, and then how many quantity needed, so 6. Okay, and also you might have some spare elements, spare parts, so you can write it like it includes spare parts, and then write here the spare part name, and then and also the drawing number. So this is a first page of the part list. If you have a lot of parts, you will have a lot of this kind of pages, but only the title page is like this. The first page is like this. So here the name of the product, okay, is also have a number here. Okay, so who did this one, who checked this one. Okay, so sign, signature dates, and this is the first page. But the next pages are easier. So in here, if you have a in the bottom, so here this one is this type, title block, but here is smaller. So next pages, so you will have more lines. Okay, so to draw more rows. Okay, so what's a bill of material? Bill of material is similar thing as a part list, but in most cases we're using a computer to list up this. Okay, so what's included here in the bill of material? Various types of bill of material might be produced. So the most cases that will have part number, description, and engineer name, who did this, and quantity and item. Is it part or assembly kind of thing? Okay, so in size, the weight and unit of measure, and used on where. For example, like if you have a product description, like a product number 1 or product number 2 is some other product, and product number 3 is different product. So where, in which product is used this. So for example, here the part number 110. So that's the name of that part is steel pipes, and the engineer Ryan okay, designed this. And the quantity, we don't have those information, so not NA. Okay, so not applicated. And is it part or assembly? So that's the part, so we can write it here. And the sizes, so you can have kind of the evaluation like size. So A is biggest, B is smaller than this, smaller than A, and C is smaller, D is smallest one. So you can differ by the size here, so A, B, C, D. And weight, so we don't have weight information, but you can include if you have that information. And unit of measure, So so each of them, it might be like same unit, like you can use, and used on product number 100. Product number 100. So you have kind of your own description of the 100. 100 means some kind of product, you know, your own some product. So if you have different product, you can use like 200. Okay, so those kind of the database or kind of a table of information about the part called bill of material, or shortly BOM. So how is assembly can be included or numbered, identified? Sub assemblies and sub assemblies in the inside of bill of material is shown in this slide. So for example, the braking system is big assembly. So the number of the braking system is 400, and all are included inside this assembly. Okay, so all other parts are included inside this assembly. So assembly might have sub assemblies. Okay, so this 410 uprights are sub assembly inside of this braking system assembly. So we did kind of, you know, we managed the numbering, like if the braking system is 400, we can use the next digits like 10, 20, 30, 40. So all are included into the 400. So that's why all our numbers are included to 400. Is includes 4, number 4 in the beginning. Okay, so 410, 420, 430, 440. Okay, let's continue. Okay, so don't worry, today's information and next the recorded lesson information is not included into the examination. Okay, so please just attend the practice classes, and the most information. Okay, so from that practice classes might be included inside the examination, and some information about the descriptive geometry, like the point finding. Okay, so the point projections and what else, dimensioning styles, those are included inside the examination. And also, okay, so the projection methods, like projections of the prism kind of thing, or projection of the parts, like isometric shape is given, so you need to find the projections. So the front view, the top left or right views, those are included. Okay, so how to assemble. Okay, so assembly names, assembly components are numbered, like 410 is the sub-assembly. This one is sub-assembly, so another sub-assembly here, so another sub-assembly. So if you have inside the brackets the numbers like bigger than 1, so that means assembly, so sub-assembly. So that sub-assembly has 4 parts. So 410 has 2 parts. Okay, so detailed parts, like mounting bolts, so 411, 412, 413, 414. Okay, so on, and that can be indented. Indented means like, so it has like this indentation. So you can do like this bill of material management. Okay, so revisions. Drawing revisions means the changes. So okay, management of the changes on the drawings. For example, you are producing some part, some drawing for some parts or some product, and you have 100 drawings, and you are producing 100 parts in one assembly. But after sometimes you'd like to change your design, and some of the drawings should change, right? So then you are changing some of them, but you have to include all of those information, the previous information, previous drawings and new drawings also. Why? Because the drawings might have some kind of connections with other drawings, the information. So that's why if you replace new drawings, and if you remove, or if you lost the previous drawings, so you might lose many information. Okay, so that's why all those informations should be saved, but the latest information should be written there, like revisions, with revisions. Okay, so yeah, those things are shown in this slide. So the changes on drawings might be necessary by changes in design, changes in tools, desires of customers. So customer might came to you after sometimes and then change his previous design, or errors that during design and production. Okay, so you need to save the previous one, but you have to write there something. Okay, so the record of revisions should show the change, by whom, when it's changed, and why the change was made. Okay, so any changes of additions might made to a drawing are tracked by a revision number. Okay, so there is a revision number. So there will be, in the industries, you will have some kind of revision control. Okay, so a department. So some person who is controlling everything, every revisions. And in old drawing, you have to write, so old one. Okay, so old drawing, so you're replacing new drawing there. Okay, so in old drawing, you have to write like this, the stamp, or some like you have to write it here like this. Obsolete means stamped like this, so that is old drawing. So you will find the new drawing about this part or any assembly with this kind of stamp. The stamp means you have new version of the drawing, same drawing. Okay, in the title block you have to write like this: superseded by, and then write new drawing number. Okay, so number of the new drawing, so you can try to find this new number drawing. Or you can have this kind of words, or you have to write it: replaced by, and then new drawing number. Both are correct. Okay, superseded also correct, and that is also correct. So obsolete, the stamp also correct. Okay, so but only you need the new number, okay, to show the new drawing. In the new drawing, so you're drawing your design, and then in the title block you have to write it supersedes, and then the old one, old number. Okay, so old number, it might be old number, old drawing might be useful in some cases. Or you can write like the replaces in an old drawing number, and then write it here. Okay, so those kind of technique is used in the industry. So so here the example. So here the revisions are shown. Revisions table is shown here, and the revisions A, the zone not applicated, so there is a no zone is shown, and the description: release to production, and date, and approved by this engineer. So another revision B. So the zone is B6. B6 means, like, if you see around the frame, you have the rectangle frame. So you have here the numbers: number 1, 2, 3, like checkbox. Okay, so 4, 5, 6. So region 6 is from here to there. So I just go to the zone with this region. Okay, so with this region. So we have B6 here. So B6, so you have to go there. Okay, so B6, so we have to find a B. So in the vertical side also we have sorry. In vertical side also we have a B, C, D on the right hand side, left hand side. So you can see here A, B, C, D. So we have a B6. So B is here, from here to there, and then 6 is here. So somewhere here. So 6 is here. So in this here region we have a revision place. Okay, so some changing place. What's a revision? So change it overall height from 1.300 to 1.250. Okay, so the height. So here also you can find triangle shape like this, triangle, and inside written B. So revision B. So this one is changed from 100 and 300. Okay, 1.3 to 1.25. So that is changed, this height of this. Okay, similar things can be done with every item. So here the B changes. Okay, so because of this change, this is affected to other dimensions also. Okay, so and the corresponding dimensions will change it by 0.5 as well. Okay, so because of all these related dimensions also change it by this. Okay, so and date who changed this one, and okay, so name of the who is changed this. So this kind of revisions can be done also. Okay, so okay, so you understand about the revisions, right? So if you have a lot of revisions and a lot of changing during your production or the design drawing production, okay, so design production, so you will have a lot of the loss, time loss, and also the production the cost will be rise up. Okay, so that's why nowadays the IT techniques are widely used in production and drawing also, okay, engineering. So here you can see the information about the PDM. PDM means product data management. Okay, so product PDM means, so nowadays product data. Okay, so product data management are used in the companies. Why? Because to manage those revisions is very difficult. Okay, so by manually, if you go, for example, the previous time before having this kind of PDM, PLM tools or IT tools, there was the department for revisions, like at that time when the all drawings done by hand and all assembly is also done by hand, like assembly drawings. So all management done by hand, and with archive, a lot of archived drawings, copies. There was a copy machines of drawings, so there was a lot of time-consuming job is done. And also errors might appear during that time. So to reduce that kind of errors and to reduce that time from concept development, from the concept development up to the production ramp up, that means the production, starting the production, serial production, needed at that time a lot of time between these stages. But nowadays, by the producers or designers are using kind of techniques or tools like PDM, PLM. So a lot of IT tools are included inside this. So they could reduce the time of from concept development up to the production. Okay, so in production, mass production, this time. Okay, so that why we need that one, because of the market. Today's market requirement is very very harsh, very in very small time. So you need to produce your product, okay, from your idea. Just you have to go to the market, otherwise the other competitors might produce and then go to the market, and then so you are losing your idea also. So that's why it's very important when you have any idea, any product, if you want to produce any product, so just you have to immediately you have to produce it. Okay, so but to production with using just hand, you will have a lot of errors, you will have a lot of the security issues. So that's why without using any IT tool, so it will be very difficult. So that's why nowadays they're using a lot of IT tools. One of this is PDM, calls PDM, Product Data Management. Every information about the product calls product data. Okay, so and then they're having kind of management tool for that one. Okay, so here are stages. So this one is stages. So product development or product design stages. So concept development, system level design, detail design, testing and refinement, and then production. So requirements. So that means so the requirements might change until this time. And the functions, features, prototypes starts from here to doing starting the prototyping, making, and tooling. Okay, so tooling to create the prototypes and all other the parts. Manufacturing process start from here. So those all are included inside a